Hey everybody, and welcome to Into the Terminal. Today we're going to be talking about bash scripting. Uh, and let's jump on into the terminal, and we'll start off with some handy one-liner commands that we can build as scripts. So one of the ones I use all the time is to find where large files are or where a lot of files are, especially when my server or desktop is close to being disk full. So let me just show you. I use du, and then you can give du a specific directory, and it'll do every subdirectory recursively throughout this chain. So by starting it off at slash, it'll actually look over the entire system. But if it was my personal system, I'd probably look in like my home directory as the starting location. So it'll tell me where all those files are stored. So it goes through and it shows me all the files. And we can instead sort them. So instead of getting just all the files as we find them, instead sort will order things. And I pass two arguments, R and N. I want it to do a reverse sort. So show me the biggest things first, because by default, it'll show you the smallest things first. And then an N says, treat this thing as a number. By default, sort will do a character comparison. So because the thing I want to sort on is that first column, which is numeric, that's what the N flag tells sort to do. All right, so there we go. There's all the stuff on my system. But notice it scrolled by really quickly. So we could do another pipe to maybe look at it one page full at a time. But because we're looking for big files, I just like to send that to the head command, which shows you the top portion of something. And I'll limit it further and say, only give me the top 20 lines. Dash N is the number of lines that you want head to show you. And so here we go. Those are these are the top most used places where files reside, or the biggest directories where files reside. And so one of the weird things is that everything rolls up to slash. So of course that's first. And then var has a directory underneath of it, which is var log. So really, var logs files also count against var, which also count against slash. So there's a little bit of reading that has to go on here. But if we look in var log, which is our third largest location of files, what we can see is one file is bigger than all the others.
Really conveniently named too.
Exactly. As no, so we can remove it. And then when I rerun my same du sort with top 20, what we'll notice is that var isn't in that top section anymore because it has fewer file. The files are using less storage, essentially. So I use this all the time for like my file system is close to full. Let's see where those files are, and are there any I can delete to free up some disk space back again.
And there's a really handy flag for DU. I just want to mention this because it saves some of that parsing, right? That'll tell it how deep to go. So you could say only go depth 1, and then it'll show you in the current directory what each subdirectory consumes. And then you're like, oh, var is the big one. Go into var and do the same thing. And then it'll show you subdirectories there, and you can sort through and say, you can kind of follow the trail that way. Sometimes it's a little easier than showing everything.
Yeah. But what we're demonstrating is that like in that one line of command, right, we actually ran several commands and hooked them together with pipes to take
Right.
the output from one into the input of the next, and take the output of that one after we make some changes to it and take it to the input of the next, where we can make even further changes or maybe look at only a subset. So this is at a very basic level shell scripting. Nate, you had
Yeah.
another example that's pretty common to use too.
Yeah. So something I did pretty frequently as a systems administrator is parsing logs, right? And parsing logs can sometimes be a bit of a nightmare. So I've got log file on my demo system here, just called error log. And this is legitimately the error log from one of my websites. If we just look at it, we can see that it's pretty lengthy. This is just like today's log. We can do like pipe it through word count -L, tell us how many lines it is. There's almost 1,500 lines in this thing. Hard to just read through, right? Also, you see that that's scrolled off the screen. There's a nice tool called less. I forget if you had touched on this already, Scott, but if we just do less on the error log, it'll let us scroll through it, you know, kind of line by line here. But again, not all that helpful. But you can see if we look back at like tail or something. Here, let's just cat it again. There's a lot of errors that look like this file not found error. Let me just find an example of one. Here we go. No such file or directory, right? Obviously, no such file or directory just means that someone's probably trying to crawl the website, looking for files that should exist but don't, or they think might exist. Sometimes that's indicative of a problem. Sometimes it's somebody trying to poke around where they're not supposed to. Sometimes it's just search engines doing their thing, right? But so this maybe isn't the best example of why you'd want to look for data in a log file, but it's a great example of how to get the data. So I'm going to kind of hone in on this particular error and give you some tricks on how you can just like pull out, say, who did this, who made the request, right? Because you can see each line tells me like what file, it tells me what website they accessed, and it gives me the IP address of the requester, which is in here somewhere. A lot of times what you're going to want to look for is, you see how there's these numbers here? Sometimes these are error numbers from whatever generated this, and you can just grep for the error number instead of having to grep for a text string, which is what I'm about to do. In this case, the error number is not always the same. So we're going to have to play it with the text string. So what we're going to do is, I've got a crazy thing here I'm going to paste in and tell you what's going on here. We're going to use grep. We're going to look for this no such file or directory error message that we see all over the error logs. Then we're going to pipe it back into grep. And we're going to tell it to look for an expression. And it's going to use this crazy regex. Now, if you're not familiar with regular expressions, or even if you are familiar with regular expressions and you don't fully understand what that is, I'm going to tell you what it is. And I'm going to tell you why we're not going to delve into the regular expression. I searched Google to find it, because typing this out and figuring it out, I would have had to have spent all week, I think, trying to get this just right. What this is doing is it's looking for IP addresses, right? Or numbers that are formatted like IP addresses, because it doesn't know if it's really an IP address or not. So we're going to throw that in there, and you can see, sure enough, it's got all the IP addresses, right? That were from that log that matched that text string. But it's still not terribly useful, because you see a bunch of these are repeated, right? And it might be really handy to try to parse out someone who might be a bad actor to see how many occurrences of each IP address we have. I'm going to skip one of my things here, and I'll just explain it. Just give me a second here. Copy and paste. All right, so we're going to add two things that we're going to continue to chain our output through. First, we're going to sort it. And the reason we're sorting it is because the next thing we're going to pipe through, which is unique, which looks for unique flags, needs them all kind of in blocks, right? So it would group, say, this block of IP addresses, but not, it wouldn't then other instances of that IP address also block in, right? So you have to sort it first.
Hey, Nate, why don't we just run it with sort? And then we'll throw
sure, we can do that. And that was how I was going to do it at first, but I was trying to save time.
It may be helpful to also clear your screen so that we get the command up at the top. Whoa, hey there,
you go with
camera.
I mean, clearing the screen didn't help that much, unless you want to see the command. All right, here, let's clear and then show you the command. So we're just putting the same thing through sort, and here it is. Now it's grouped all the IP addresses together. See, like this 219 address is all in one block. This 192 address is all in one block. This 46 address is all in one block. And now if we clear it again and add in unique. Unique, what it would do is just deduplicate it, right? You can see now all those IPs that were duplicated are just single lists now. But if we add the -C option, this tells us how many occurrences of each address showed up, right? And you can see this one's here 14 times. This one's here 27 times, right? But this list still isn't great because look here, 97, which might be indicative of a problem, is way up here, like off the top of my screen. I'd have to then parse through and see what's what. So we're going to now add in sort again, which sounds repetitive, but we're using sort again for a different purpose. We're going to sort it again with the -n option that Scott used earlier, except I'm not going to reverse it because I want the big ones to show up at the bottom because that's what's going to be on the screen. And here, let me let you guys see these a little bit better. Right? So sort -n tells it to sort it numerically. If I added the -r, then the big ones would be at the top. In this case, they're going to be at the bottom. And you can see my 97 is all the way at the bottom. So that one shows up right there in front of me, which is helpful. And I can also see that, you know, the vast majorities are like 1 or 2 hits, right? A bunch of 1s, then some 2s and 3s. But, you know, these might be either someone trying to beat up my site, try to find stuff they're not supposed to, or it might just be Google, you know, indexing my site and looking for stuff that it knows might be there. It wants to see if they are.
So stay with us after the transition. Don't forget to mash that like and subscribe button. Because Nate, like, we're going to take that and do what with it?
We are going to make it easier to deal with because obviously that huge regex, you're not going to remember to type that every time. And so this means you're going to have it pasted somewhere and copy it out and throw it back in whenever you need it. So we're going to make a reusable script that'll take that thing and put it into something that's a little more versatile.
All right, so we'll check out taking our one-liners and converting them to more structured shell scripts when we see you on the other side.
Yeah.
All right, so I do have a couple of quick notes. One is regexes. Man, okay. I'm sure
Mhm.
everybody looked at regex and went, holy cow, how does one make that thing? So one is you can spend hours, like some people, learning how to make really complicated regexes, which is short for regular expressions. Um, or you can look for examples and other stuff of people who have already made those regular expressions. You just copy paste. And Nate, that's what you chose to do, right? Because more efficient
Yeah.
use of time.
Yeah, exactly. I did a quick. In fact, it wasn't even Google; it was DuckDuckGo, and it even came up with in one of those little sidebars. It just said, "This is the regex you want." So it's apparently common enough that they've got this stored somewhere, cached. But yeah, I did find a nice article that explained several ways you could get IP addresses, and this was the regex I decided to copy out of somebody else's work.
Yeah. And the other thing with regular expressions is you can spend a lot of time crafting a extremely explicit regular expression that only matches the exact things that you're looking for. Or with a lot less time and trial and error, you can get something that's pretty darn close, and then use tools like sort or cut
Yeah,
or a second grep to
yeah.
like weed the things that you don't need.
I'm going to be totally honest. Normally, what I would do, because I wouldn't deal with that regular expression, I would make a command line with all the chaining and whatnot that I needed to take that line from the error and use like awk to chop out the IP address. And then that's what I would display to the screen. Right. And then I would do the same thing with sort and unique and all that stuff to get the data out of it. But then I thought there must be a better way with regular expressions because you can like do anything with a regular expression, I think. So I
You're
looked
darn
it up and
correct.
thought it'd be fun for today's example.
But there gets to a point where one-liners get too long, and you certainly don't want
Yeah.
to type them. So Vincent in chat actually said something earlier about having an alias, and that's a fantastic thing to do because then
Yeah.
you can have a shorthand thing that actually runs this big, long, gross thing that you've made, and you don't have to type it every time.
Right.
Um, but another approach is if this is something you use all the time, you might want to actually make it nicer or
Yeah.
have additional functionality that isn't really something easily introduced into a piped giant one-liner.
Right.
And so when you're in that state, what do you do, Nate?
So, I mean, any command that you throw into the command line could be thrown into a script. And if we hop back into the terminal, I can show you quick the super basic rendition of turning this thing into a script. So we're going to open up a new file. We're just going to call it ips.sh, and then we're going to paste in this thing, which is basically the exact same thing we just did on the command line, except I added a shebang bin bash to the beginning of it, which tells our interpreter, or I should say it tells bash or whatever you're running it from, what interpreter to parse this with. If you were using Python, you'd use a different one. If you were using SH or CSH, you'd put that in there. This is a bash script, so it's bin bash. And you can see it's the exact same command we just did. We're going to save this, and then we're going to chmod it +X. If you watched a couple episodes ago, we talked all about what I'm doing here. You can go check that out if you want to learn about file systems permissions. We're going to call it, just chmod +X, make it executable, and then we're going to run it. And look at that. It gives us the same output that we just did in our one-liner. And now it's repeatable, right? If we ever want to do it again, you just run the shell script.
But we can do more with shell scripts, right? That didn't get us any additional features or benefits, right? We could have done that on the command line. So
That
what
is
would we
true.
do that would make it
All
even
right.
fancier?
So to make it fancier, we're going to have to, you know what, let me copy it to, well, I'll just do it in place. So we've got, the crazy shell script. We've got the crazy regular expression in there. That's kind of hard. It's kind of hard to read on the fly. It's also, you could get into a situation where if you're trying to change that regular expression with it in line like that, you can sometimes end up accidentally changing some syntax that breaks the script. I don't know how many times you've been in there, you change a quote or a double quote, and then it's like, oh, where was that closed? Oh, I deleted too many characters. What was it? Sure, you can back out of those things, but I always find it easier to take complicated things like that and put them into an environment variable instead. There's already an insert mode. So let's go, we're just going to call it regex. We're going to enclose it in single quotes because this tells it to ignore any bash interpolation that it would be doing here, interpretation that it would be doing. Just kind of paste it right up here. And then we're going to close it in a single quote.
Want to make a note about that variable. So originally when we were putting this together, Nate used caps because I think if you look at the variables that are set in your environment using the set command or something else, variables are in caps. So like, why wouldn't you use them in caps here? And I will tell you that I always use lowercase variables or mixed case variables when writing scripts. And the reason is because I know that environment variables are all caps. So if I do something like term or path, it's going to overwrite the environment variable of the same name. But if I use lowercase, there is never a worry of conflict between what I'm doing in my script with setting and changing variables and what may be in the shell environment that may be used by the system or shell interpreter.
That's a valid point. I never really thought of it that way. I usually make them capital so they stand out in the command line, just personal preference. But that's a pretty good point there, Scott. All right, so what we did is we put the regex into a variable, and then we put the variable where the regex used to be. Now, I put it in these curly braces because that treats the variable a little more. I'm having trouble coming up with the word.
It defines the variable explicitly. So if
There
there
you
was
go.
surrounding text, it wouldn't blend in the variable name with the surrounding text. It
Right.
isolates it and says, this is the variable reference I'm doing. We probably, in this example, we could have done just $regex and it would have been fine.
Yeah.
But using this curly brace offset is a good habit to get into.
Yep. So let's save this and then let's just make sure it still works. Right. And there you go. We still have the same output. But again, we made the script a little easier to read. but we still haven't really extended its functionality at all. So what I really like to do with scripts like this is make it so that this file name that we're parsing is not hard-coded, right? So right now, every time I run this script, it's going to look for a file called error log in the directory that I'm in and try to parse it through this command line, or through this chain of commands. And that's not explicitly all that helpful. So what I want to do here is, first of all, let's tell Vim that that it should not be doing syntax highlighting, because I want to copy and paste this out of my notes instead of typing it all live on the show. So we're going to, first of all, just make a few new lines here. We're going to paste this in. Hopefully copying from my Google Doc didn't break anything here. Then we're going to comment this last one out because we don't need it anymore. Because what we've done here is we took the file name. Now, if you're not familiar with this, when you invoke a bash script, if you type something after the name of the script, so if I did /ips.txt or .sh and then some word, that word will be thrown into a variable called $1 as the first argument after the name of the script. $0 is the name of the script, just fun fact, right? So if you needed to check if I was ip.sh, I would check if $0 was ip.sh, but of course it is, because that's what we ran. But there are reasons you might want to do that in the future. $1 is the first argument. $2 would be the second argument. $3 the third. So there's this array. I guess it's not an array. They're separate variables. Other interpreters treat them as an array. Bash does not. So what I'm doing here is I check if there is a variable that has data in it called $1, right? So this tells the script, did I type something after ips.sh? If I did not, right, because this returns, let me think, this returns 0 if it is empty and 1 if there's data in it.
So what the return code is going to vary based on the thing. So how about we say
Right.
it returns successfully?
Okay.
Or not successfully.
Right. So if it exists but it's empty, it'll say, hold on, you need to specify a file. Because if I didn't specify a file, then when I get further on and I try to do the grep and everything, there won't be a file name to throw in there, right? And then I check if there's a file named the thing that I typed. And this could be a full path. It could be a local file, like a file in the same directory. It doesn't care. It just literally looks for that path to see if there's a file with that name. And if there is, it'll do our grep stuff on it. It'll search for the no such file or directory inside of the file. It'll throw it through that regex that we still have up there in that variable. It'll do the sort and the unique and all that stuff. And notice where the file name used to be, I now have $1. And I did not put my curly braces around it. I'm sorry. There we go for not being uniform, right? If it did not find a file, or the file is not a file, because that's what the -f does. If that's a directory instead of a file, I believe it returns a not success, right? In which case it would say it's not a file or it doesn't exist, right? And then it'll exit the script because it got to the end of the if statement here. All right, so if we save and close this, clear the screen here. If I do ips.sh now with no command line arguments, it should give me an error. You need to specify a file. Okay, so let's just like put in some file. It should say, that's not a file, right? Which is exactly what it did. But if I type in error log, there we go. So now what I did is I took my one-liner and I made it something that I can give it any log file that I want to give it. And anything that matches the format of an IP address should get returned by the script, right? So this could be super useful and reusable in the future. And reusable
So Nate,
good scripts.
If you can go back into your script, there are a couple things in your syntax there that I wanted to mention. Because we're like throwing a lot of people new to shell scripting.
Yes, exactly. I just ran through all that. Sorry.
So Nate introduced a control structure called an if then else. So an if then else is I'm going to test a condition. And if the condition is successful, I'm going to do something. Else, I'm going to do something different. So, and there's some chatter in chat about like how one would test. So, for example, Vincent said, "Well,
Yeah.
I would test this whether the if the file or if the file name is there, and then do my stuff, and if the file name is not there, then do an error message." So there is a lot of like how one chooses to logically orient their control structure.
Yeah.
Um, there's no wrong answer. Um, as Larry Wall, who was the original creator of Perl, once said, there's more than one way.
Always.
So, yeah. All right. So we have this control structure that allows us to make decisions, to check a condition and make a decision and decide what branch of code we want to execute based off that decision. The other thing is that thing in square brackets. So
Hmm.
that square bracket thing is called a test. And there's actually a command also called test, which does the same thing. So that is the condition that you want to test, that you want to check. So it can be a lot of things. It can be running a command and whether that command is successful or not. And that's actually what
Right.
we're doing here with dash Z.
Yeah.
Dash Z is a command, and it returns a success if the thing that it's passed is a zero length thing. So if there's nothing stored in this variable, it's zero length, and that is a successful return for dash Z. I
Right.
think there's another one called dash N, which is non-zero, if I remember
That's
correctly.
possible.
Um,
I had to
so you-
dust off some bash foo to make this script, and this was the first one I came across, and time crunches and all.
yeah, yeah, for sure. And then you can see that we have another test that's the dash F if the file exists. There's also a dash D to see if it's a directory. There
Hmm.
are tests to see if it's executable or readable. So you can actually check like all different properties. All of these little they're actually built into the bash shell. So they're called bash built-ins.
Hmm.
They're actually documented in the bash man page. So if you're interested in finding more of this, you can find it in the bash man page. There's others like equality checking, so equal or dash EQ. There's greater than and less than checking,
Yep. Lots
all
of
kinds,
numeric checks like that. Yep.
or string checks also. So
Yeah.
comparison operators, I think is the term to use.
Another thing I wanted to
Hey,
call out quick was how I broke up this line here. I don't know if you had something else you wanted to touch on there, or is that where you're going
ask
next?
you about next.
All right. So the original command was this big chain of things. In fact, you can see it down here, right? It has all these pipes and whatever's, right? And it makes it kind of long and hard to read. So all I did here was there's a special backslash that if you've ever seen anybody that put anything up on a web page to show you bash ever, they almost always use this to make it more readable. And all this does is it breaks the command up into several lines. And my formatting got messed up when I pasted here. Normally, what I would do is so this is the first line of the command here where I have my cursor. I would take the sub pieces of it and indent them by a couple spaces so that you can tell where you're continuing the command, right? And then once I moved on to another command, if there was something else I wanted to do, I would then take that back two spaces, and that way it's easier to read.
So I have a different approach, Nate. I actually don't like backslashes, and I just put the whole big, long, disgusting command on one line, and then I'll just resize my terminal so I can see it on one line because I'm lazy.
That's another way to approach it. I hated backslashes for a long time, but especially when I started doing examples and demos, I decided to start using it to make things more readable.
And then I think the only other thing that we haven't talked about is echo command. What's echo?
Oh, Echo just prints something to the screen, right? So you can have it. You can also have it do something like prompt you for the name of the file. We didn't talk about that either, but we could say Echo, what file would you like to grep? And then, or I could have it in the control structure there that says instead of you need to specify a file, I could have it ask you for a file name. Echo the thing, and then have it. What does it read? I think is the name of the command we would use for that. That just
Yeah.
reads in from the terminal, right? So you could type in error dash log. But if you specified one, it would just do the thing instead of asking you.
And echo is the traditional bash built-in for this. There's actually also printf. So if
Hmm.
you wanted to do edit printing or you're from another background like C, where you're more familiar with printf and using it, you can use it in Bash too.
Right.
But the big thing is like you're running this command and you have to have the shell or the script has to have a way of communicating data back out to the user while it's running. And so echo is how we put in our programmatically our
Right.
outputs want to be presented to the user.
Every language has one. It's either print or echo, or remember back in the basic days, you could replace print with a question mark, which was always confusing in code later, but it was so much easier to type.
So we do have a question from Vincent
Okay.
about double bracket. So double bracket is a thing, but it's for arithmetic. So if you actually wanted to have the shell do math, that's what double bracket is used for. Because
Yes, agree.
computers are math, so why not
Yeah.
make them do math shell? All right, if we'll leave the chat open for a couple minutes, but we're actually like right on time. Nate, what's happening? Producer
I don't
Eric is back.
know. It's like we planned a good length demo with discussion, and now we're like, but we're not over. Should we keep talking?
All right, I don't see anything else in chat, so hope you enjoyed the introduction to Bash scripting. I did want to give you a takeaway though. So we're trying something new. If you are interested in more things, there's actually a great lab that's available on lab.redhat.com called Helpful Commands. And I think producer Eric will throw it up in just a minute. But if you go to lab.redhat.com, it's called Helpful Commands, and it goes through things like the df command, grep, and using some simple regular expressions with grep. What else? I told you a list today, Nate. Oh, locate for finding files.
Yep.
Like
Locate was in there.
so,
But
if you're looking to,
does it give you a regex that'll find an IP address in a log file? Because that's what I really
it
care about.
it does not. It's more use of grep. But if you're looking to build that command lexicon, right, your command
Yeah.
vocabulary,
Yep.
um, it'll give you a few good ones to help build that vocabulary.
When I was getting started in the industry, I had literally a notebook that I kept in my backpack full of just like one-liners and whatnot that I found useful. Of course, as time progressed, became a lot more efficient to put that into like notes, the notes app on my phone or something. But eventually you get to memorize them and you don't need the notebook anymore. But just a suggestion, right? You come across something that really did the job, write it down somewhere, either in a notebook or in a notes app or whatever it is that's handy for you.
All right, so next week we're going to be doing more with scripts.
Yeah.
I don't know what
Gonna go
that looks
more.
like yet.
Well, I mean, we talked about more advanced stuff, so we're gonna do. I don't know. I mean, I feel like we got super advanced. We're done. We've solved all the scripts, Scott. I don't know what we're just gonna hang out and drink with our viewers next week. What do you think?
Well, I think we should cover some more control structures.
Oh,
So one
okay.
that I use a lot is for loops. That might be handy to go through.
Oh, I love me a
We
good
can
for loop.
exactly.
We could talk about
What
sed
about
and awk too.
you? Well, said yes. Um, the other thing that I would like to mix in next week is using other systems. So maybe we like throw in some SSHs and so that we can actually execute on other boxes too.
Oh
That
yeah, that's fun. That's fun. Better watch it, Scott. Soon we're gonna be talking about Ansible.
uh, Ansible's great.
I know it is, but it's not bash scripting. That's my point.
It, it is not. All right. So join us next week for a more in-depth shell scripting, where we'll talk about some more components of shell scripting, give you some additional examples of how you can apply this to your real life. And then also, Eric is doing RHEL Presents in another couple weeks. But then after that episode is one that is queued up for password authentication with Yubico. So there's been
Yeah.
like Yubico support in RHEL recently was integrated in a bunch of stuff. Actually, Nate, you probably know more about that than I because
Still got my key on my desk here from the demo that I just did. Yeah, so there's a demo video out there. It just went live on the RHEL YouTube channel. I think it was this week, maybe even late last week, where we have integration with Red Hat Identity Manager, and YubiCo was a great partner here. They helped us work in FIDO2 support, so you can map in a key to an IDM user and authenticate across the the IDM domain using that YubiKey, which is actually pretty cool. So go check out that demo. But yeah, we're going to talk about it on RHEL Presents with YubiCo.
Awesome. All right. Well, we will see you all next week for more shell scripting. Don't forget to mash that like and subscribe.
Yeah.
See you all later.
If you can do it once, do it. If you do it twice, script it.